Hello, and welcome back to Reconstructing the World.
Welcome to Reconstructing the World. Welcome to Reconstructing the World. Welcome to Reconstructing the World. We are back. Welcome back. It's time for Reconstructing the World.
For the next year, we're gonna follow the construction of this baby. One material at a time that Anders and his team came up with. It's gonna be super exciting.
As Anders mentioned, this baby is a building that we're building right now. It's probably one of the most sustainable buildings in the world right now because we are only building this out of materials that are known as being super sustainable. Even some materials that doesn't even exist. So let me just explain to you guys what this actually is. It's an 80-meter high wood building, and normally in Denmark you're allowed to build 3 stories. That's down here. And we are building all the way up here with massive floors, slabs in wood, and columns also in wood.
Here we are. And here we are. Fantastic. Right? Anders,
It's beautiful.
you fucking did it.
Yes.
You built something out of wood. It's very nice.
So now we are up 4th floor, and the wood beams, the wood floor, the cores.
This is the actual wood point.
This is massive wood. But the thing is that when you build with wood, you have the ability, because it's, of course it's heavy, but it's not as heavy as steel and concrete. So you can transport more pieces at a time.
Yeah.
And you don't want to move air. So there's
It's like
balance.
IKEA.
It's
So this is really big time IKEA.
it's a very big IKEA system.
But it looks so nice. Look.
And smell it.
Look.
Smell it. Yeah, it's so nice.
Oh,
it's really tree hugging.
This is, of course, we are playing to the camera, but actually, because I know a fucking lot about building material, right?
You know
The
everything.
thing is, when you see this quality, when you see this this way of you know, I may be over exaggerating, but I can already feel this is a fantastic building to be in.
Yeah.
Look, I'm a tree hugger.
But when you look at how much wood that's harvested today,
Yeah.
production wood, forest, and so on, only 1%, actually 1% of all the wood that we harvest is used for building.
Because it's used for this.
No,
It's getting used for this.
No, it's not even used for that. It's used for paper, packaging, all other kinds of stuff that has the shortest lifespan ever, which means it makes it a problem that we harvest forest.
Yeah.
But if we put it into the buildings and they are there for many years, then it makes sense. And the interesting part is, if you would build everything in the world out of wood, then it would only be half of the amount of forest we have today used for that we harvest. This is the facades of the building.
Okay.
And the interesting part here is that it's all light material, so it's a light facade.
Yeah.
And when we say it's a light facade, then it's the opposite of the heavy, which is concrete and
Usually
bricks,
is
of course.
the opposite of light
heavy
is
stuff.
usually heavy. I'm just saying. I'm just saying.
You know, getting us started here. And usually the whole structure in these wood elements is steel. So when you have these.
Sorry, I was having a discussion with one of the builders who's actually building this.
Yes, it's not
beautiful
you building
thing for
it,
you.
it's them. They're the builders.
But we should.
But what I was trying to explain
Yeah,
here
sorry.
is that these studs and structures inside this element
Yeah.
is also wood. And normally it's steel.
Yeah.
You don't see it in these elements, but everything's steel.
Yeah. This is the beams. This is the beams that hold each floor, right?
Yeah.
Let's talk about the structure. What is this built up? How is it built up?
So all the columns, they need kind of their main job is to take all the weight and the load of the building vertically.
from floor to floor, right?
Yes.
So this
all
one,
the way, everything that's piled up. Now we are on the ground floor,
Yeah.
and we're going to have 20 floors all together. So there's 90 floors on top.
this is built of wood that is. How's the structure of it? Is it the cross laminated thing, or is it a?
No, this is actually a kind of a classical old glue lamp structure. So it does have glue in it.
Yeah.
And every piece, and you can actually see here that they're quite wide. I mean, it's quite big pieces that are laminated together.
And how? So I can see how long it is.
Yes. And they, of course, have an overlap so that they stabilizes themselves when they're kind of like brickwork almost, right? So they have different lengths, so you can use different pieces as well to do that. But the thing here is that they're all going in the same direction.
Yeah.
Because a piece of wood is way stronger in kind of on the long side, taking pressure, where it bends out, but where it's the other way around, it bends down. So that's why they're in that direction here.
But I have a question in terms of sustainability. The amount of glue and chemistry in this is nothing compared to other kind of materials, or how is it?
It's of course we've been looking into how much chemistry there is in this glue, and from the 70s back then we didn't care about what was in it.
No.
Now we have a totally different control of what is in it. But it is an element that we would have loved to do something different, and it is actually possible to do something different. You can have small, you can say wood screws, or you can actually have nails in it, so you nail them together.
Like really old kind of buildings technique.
Where you basically shoot them together, and then you have steel pieces.
Okay.
And that's of course interesting because one thing is the sustainability part on CO2, but there's also the fact of off-gassing VOC, volatile organic compounds that are part of that equation. And so here it's optimized as much as possible, but there is glue in these. This is a really nice spot in the building. So there's this mezzanine put in, and then there's going to be, the reason why there's a hole here is because there's a staircase going up. So we're going to be able to come up. But what we can also see is that instead of having the linear wood pieces as in the
from the columns, right?
Yes.
So the columns are built like this.
Yeah, and here we have a cross-laminated timber structure.
Okay.
And which means that we have them going across.
Okay.
Quite simple. And that's because we need this piece of the building to be able to take forces more horizontal and not just in one spot. So it can't bend down. It's not allowed to take loads in the middle the same as our columns can do, but it can span 6 meters.
Okay.
Because it is a hybrid building. We have to acknowledge we have some concrete, we have some steel, and we have a lot of wood. So there is 4,000 cubic meters of wood, so it's a lot. So that's good. But what we hoped we could have done when we started the design was to have beams in wood as well. So a column and a beam structure. So it's almost, I call it a grid structure.
Is that a beam? This one?
That's a beam.
So you wanted these beams to be replaced with wood?
Yes.
Okay.
And on top of them, you would put our CLT slab. And that would have then been a bit lesser or smaller in dimension because it would be load bearing on the.
And why didn't you do that?
And that's the good question. Why didn't we do it? We didn't do it or weren't allowed to do it because then it would cost something in height of the building. So each slab is optimized always to have ventilation, acoustics, ceilings, and a kind of optimized room height. Here we have 6 meters high floor, so it's not a problem here. But then the building would have ended up being
higher. How much higher?
1.5 floor higher.
This needs to be collaborative, right? It needs to be a collaborative between the developers, architects, the providers of the material, and really, really important, regulators. You know, the municipality. I fucking can't.
Municipality.
Municipality needs to wake up, because the guys and girls who sit in these offices and makes decision about regulation are actually the gatekeepers for this, for acceleration of this.
And government.
Exactly.
So today, the material we're going to look at is probably one of the most sophisticating upcycled products that I've tried to work with.
Let's start with the problem, Anders.
Yeah.
Let's go through the problem that made you investigate how to use windmill wings as a sunscreen.
It all starts almost 5 years ago, where I'm presenting actually for the windmill industry here in Denmark. And I was just curious, because everyone, embraces renewable energy in the windmills. So do I. I love them. But then I asked, so what happens when they need to be taken down? Or
The wings or the towers?
The
everything.
whole thing.
Okay.
What happens?
Yeah.
And no one is really saying anything. They're like blah 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 blah.
And
then something like this happens. And the fact of the matter is that there isn't really any solution for the wings, which is fiberglass and balsa wood. And so what to do with them? And since we have so much waste, and what we're seeing here is that we're going to have around 102,000 tons of windmill wing waste within 2025.
this is an actual end of a windmill.
This is the tip of the spear, the tip of the windmill wing. So as you see, it has kind of a structure inside.
This is one of those that is being transported on the highway.
Yes, this is actually from the first windmill farm in Denmark that was taken down a few years ago, and that was kind of the beginning of looking at this as a potential when you start to cut it down. I mean, isn't it beautiful?
It is actually.
I mean,
it is actually like a wing on a plane, right?
Yeah. So we decided to use kind of this part and cut that out, and we have an example. If you hold that one.
Yeah, I will greatly hold
then-
this enormous wing for myself. It's
Then
not
this is
a problem
a
at all.
small part cut out.
And that is from further in. This is not from the tip. This is from one of the big ones.
This is from the beginning of the windmill wing,
Okay.
and so we could cut out a lot of these pieces.
This is fantastic. Fantastic.
This is groundbreaking material, right?
It is groundbreaking. Fantastic.
Yeah. And who's this guy?
It's our best friend, Morten.
Hey guys!
Oh, I didn't know. Hi.
Good to see you.
Hi, best friend.
This guy.
And what does Morten do?
Morten, I can explain just
Please.
a little bit.
Yeah, because he can't talk.
He can't talk.
That's very
yes, yeah.
important.
Morten, he's making windmill wings become a building material, and that is so fantastic and wonderful.
Those
So
over
he's
here.
a magical guy.
Okay. So on the model in Copenhagen, we saw this small thing on the model.
Yes.
Morten is not that small anymore.
No, these comes out of 63 meter long wind turbine blades. But when they are dead, they are a huge issue because this material doesn't degrade.
Yeah.
And it's quite difficult to do anything about. So right now they're just laying, and we have gotten 3 wings that we are now cutting into pieces.
Is this one wing being cut in?
This is
in
actually
various lengths?
just a third of a wing.
So you got the idea of saying we need to take these wings, we need to use them as material.
Yeah.
And on Tre, the building we're talking about now,
Yeah.
this is sunscreens, right? You can just take it, Morten. It's not live.
It's
You can
someone-
just take the
someone
phone
calling
and,
us.
No
Yeah.
problem. So, guys,
Yes.
now we need to talk about the very concrete business of cutting this up so it's a usable material, right? So first step was cutting this.
Big wing going to small.
Yes.
And the process here is that you have 63 meter wing. It's laying in the other side of Aalborg. Right now we are in Aalborg East,
Okay.
they are in Aalborg West. And out there, the big crane lifts them up. And then first process is to move them through Aalborg. So they are basically taking down all of the lighting poles, I believe you call it, and then driving them on a big truck.
But you don't cut them before?
No, because they're not allowed to be cut at the place that they are stored right now. So
Oh,
big
shit.
wing moved, And then the third thing is to cutting them into these pieces we see here, 5 meter long. That's with a long wire saw that goes around them, and for 2 hours it cuts one cut.
Okay.
So just as you can see here, that would be 12 hours of cutting, right?
And that's you know, comparing to other types of sunscreens on buildings, you need to take a material that was not made for this and somehow streamline a process that can make this material. Because I can already think, if you need to cut it over and you need to transport it through Aalborg, the product is already...
But you have to remember that these things is actually something that's happening no matter if it's becoming a product or not, because it's a waste wing.
But it doesn't
you need to take it down, and then you have to cut it up and move it, and either you put it as landfill, and that's also cutting and transporting, or you incinerate it somewhere in Germany with a really high degree of temperature. So that part is kind of, we have to move it anyways.
Okay.
Now we just move it here, and then we start working with it. When you do something, it's a new prototype, and it's an invention. So of course it comes with a price, and we are pushing something that everyone saw as like no solution at all to the building sector. So that costs. But it is probably twice as expensive as if we have chosen to do an aluminum facade. But we're also saving 95% CO2 on doing this. So it's really
95%
and taking care of a huge waste problem. These have been put in the ground. You would dig a hole in the field out there and then put it down and wait for it to, well, it doesn't disappear.
No, stays for 1,000 years.
So it's a landfill product.
So we can use it for 1,000 years, that's what you're saying.
It can stay on the building for a long time.
It could be storing it.
Okay. Every time we're working with waste, it's not the same. And that's something you as a customer should also be learning to accept. That
I think it's a very important thing you're saying. Is that Morten is saying a very important fact is that if you want to take waste and turn it into building materials, normally if I order building materials, it's all the same shape, like the bananas in the supermarket, right?
Yes.
So a big part of changing to the new material is saying they are not the same shape.
Accepting the odd bananas.
Okay.
Yeah.
Hi.
Welcome to.
And so Jonas, the reason why we're here is because this weird character decided that he could use your windmill wings into products.
Yes.
And Jonas, what are you at Siemens Gamesa?
I'm one of the sustainability freaks at our company.
Okay, great.
I'm trying to improve our processes and products for a better world.
And what is the problem?
So the problem is that the chemistry that we use, so the epoxy, is difficult to dissolve afterwards. So it is composed of multiple materials and it requires a lot of energy to separate it. That will deteriorate the value of the materials and drive up the cost. So there's no cost-efficient ways of recycling, reusing the blades as of today.
So this is after it's been sitting somewhere for a long time.
And just so, Anders, how did the process end up at Jonas? When you said you wanted to make facade elements or sunscreens?
Well, it started. We heard that this was a problem, and so we thought, okay, let's help the industry if we have a good idea. And in this case, we had to understand the windmill industry, because how old are the windmill wings? How many are there actually? And are we actually seeing that it's who's taking them down? So we found out that there is very few that are actually the waste handlers of windmill wings in Denmark. That's few companies. Yes. And then we started to talk with each other, and then we found Jonas.
But I just wanted to, is it that concrete so you understand there's a waste problem? Then somebody calls Jonas and say, hey Jonas, and you're sitting in your office saying, I have a waste problem, I don't know what to do.
Yes.
And then what?
So we are always interested in finding solutions to challenges that we have. Anders and the team came basically with a good idea that we could see potential. What we have been working on is recycling the material. Here we are basically recycling the structure, right? Yeah. So we get functional value, extending the functional value of the blade, and we found that interesting for this project.
I mean, what do you think is the best solution for this now? I mean, we're looking into a time where we have a lot of this. So
So do you have other kind of ways to go, or is this what we're doing here? Is this really something that we should do more of and scale up and so on?
I think there's two legs to that. What we're doing here is extending, you could say, the functional life, right? I think we should find all the applications. You know, we have the bike shed also, so of course we should maximize the use of that.
Yeah.
And then the second step is, what about then after these 50 years, 100 years in the building, what are we doing with composite waste? There we are relying on mechanical, thermal or chemical processes for recycling there. So I think it has two legs to it, yeah.
It is very exciting. Today we're talking about the facades, and I think what
So
we have
keep
to,
on track.
We have to remember, to keep on track, but also to remember that basically all building facades could be made out of waste materials.
Okay.
And one of the paradigms for this is that form starts to follow availability. That's a paradigm shift in how we design buildings and how the facade starts to look. We had to look at the materials that we have in hand and then start to shape the building from what we have.
Okay.
The new material, there's some of it right over here. But there is another mock-up, a test we did.
Like this is a mock-up.
That's a
Mock-up is, you know what a mock-up is. But this is a mock-up. So it's like a test of what you were thinking, right?
Often we see problems where we have discarded materials, and one of the materials that are the lowest in the hierarchy of beauty is these trapez and sinus steel and aluminum sheets.
And you see them on farmhouses,
everywhere,
barns, all over the countryside where you need quick building materials, cheap, up in a fast way.
Yes.
There's tons of it.
Yes.
It looks super crappy.
Super crappy. But the facades or these steel sheets, they and steel in general is a huge challenge because they are usually on buildings that lives very short.
Yeah.
So they become waste. And when you have steel waste, you need to find a way to recycle it.
Yeah.
But you use so much energy to recast the steel.
As a recast, meaning melting it down. Taking it up so you can make beams and...
So you can make something else.
Okay.
So the best thing you could do ever was to find a way to direct reuse the material.
One to one.
Like
with very little energy, just reuse it.
Yes. Now we go into to nerd attack. Of course, it's fun just to drive over the sheets.
We haven't got to that part.
No, but it's coming. But if we have to go into nerd attack here, we need to have some data. So what is our client's biggest fear when you want to recycle?
Spiders.
Spiders and corrosion.
Oh.
And there is a corrosion classification, just as you know classifications of danger of spiders.
Yeah.
It's basically the same. So in this case, it's corrosion. Corrosion is when steel in the mix with air, moisture, salt, and other chemistry starts to deteriorate and disappear.
And become rust.
Which
sparkle
is
into the
corrosion.
universe.
Yes.
Okay.
What we found out was that one of the reasons why we're not recycling this steel and aluminum is because there's something called corrosion classes. And these classes are defined in the 70s because we had a lot of pollution from cars in there because they were polluting.
Because of the lead in the...
Lead and NOxes and everything that came out of the cars. And we had a lot more industrial factories close to the cities. So the cars were, corroding and everything were corroding. And because of that, there were standards. But what we found out was that when we look at salinity, which is how much salt there's in the air, it's not that high when you look at Sjælland and Midtjylland.
And we are here.
And we're here, yeah, exactly. And also when we looked at how much chemistry or sulfur on us, that's not a problem anymore either.
Because there are no dragons.
There's no dragons, there's no factories close to the cities, as I said, which means that now we can control, or at least we know that the corrosion of these sheets are going really slow. So even though they've been on a building, these ones that we were driving over, or going to drive over.
Don't say it.
I'm not used to this.
No,
I'm
you are
spoiling
not.
it.
Not. So
If you were to do something about these things.
If you were going to somehow make some funny thing with an electrical car and those, yes, that would then
Unless
be
you're spoiling the whole thing.
Shit,
Don't say it.
We're really bad at this. We're both really bad at this.
So the fact is that these sheets are just as good as new. But today we are remelting and recasting the whole thing instead of direct reusing it. So as we saw on the life cycle.
So, to make it short, you found out through testing, your own testing again, your own LCAs, your own, technological institute trials. You found out this is more than ready to be made to a facade material.
Yes. No, we found out that maybe these facades would be a little bit monotone, a little bit boring if it was on 5,000 square meters. So we said, what could we do with these sinus sheets or trapez sheets to make them look different?
And what did you came up with?
We came up with a super easy solution. What if we just drive over the sheets with an electric car?
Okay. And imagine what we are going to do now then. Welcome to the dramatization of Anders Lendager, most sustainable architect in the world, getting the idea of flattening a steel panel for a facade on tray building, starting now. What are we doing?
We're going to see if we can make kind of a new facade out of this trapez sheet.
So this is going to be a new facade.
This is how we start testing it. So we need to drive over it with something really heavy. Do you have a car?
It's a reconstruction.
We're reconstructing.
Do you have a car?
I have one.
Well, is it electrical? We only use electrical cars in the production. I have an electrical car.
I have one as well.
Let's do best out of three. Which one? This is actually how Anders got the idea of
this. Yes.
I'm gonna go to my electrical car.
Lucky bastard.
And you can guide me, Anders.
Okay. The idea is that we want to change the shape of this sheet to make it just different. And so what we want to do is to make it as flat as possible. So this was the first start of how we could do it. So let's see if we can make it flat by driving over it a couple of times. You just hit it with your front wheel. It has the exact same shape.
It's extremely disappointing. So the steel plate didn't work for the reconstructing of flattening, right? So what have we done now to exemplify this?
We've changed to a different material that we're also going to recycle, which is aluminum sheet.
Oh, so this is not even being, that idea is not even being used in a building already?
No.
So this has never been used?
No.
So this is not reconstructing anymore. This is real time,
one-to-one.
Real R&D. Fucking love it.
See, now it starts to deform, right?
Now
it starts to change a little bit, right?
You have a very low.
Well
Thank
done.
you for the and that ends.
But we're going to show how it's going to look, because of course it's not going to be made like this. Let's go and check it out.
Let's go to the material room and talk about the rest.
Yes, let's go.
It has small dent. Yes, and after a very successful reconstructing of Anders getting the idea of flattening, I succeeded flattening it with my car. And it nearly looks like yours, right?
It's this is how it has to look. I mean, I took my car. It was a little bit more heavy. Also, an electrical vehicle, right? So this was the real test, and this showed us that maybe by kind of putting pressure on the trapez sheet, it starts to create these beautiful, magical surfaces. What about yours? How does that look?
I have 0 beautiful surfaces on mine. But of course, this is about the most sustainable architect in the world, Anders Lendager, and not about me. So let's continue.
It's okay, Anders.
Yeah, let's continue.
You're good at so many other things. This was what actually showed us that we could change it, right? And so we said, okay, could we go even further? So I'm sorry about all this noise.
No, but very quickly, it looks like this from the start, right?
Standard trapez sheet, as you see it everywhere. Sorry about the noise.
Yeah. So you flatten it like this, found out, hey, it's not a sustainable way of flattening things.
Yes. And then you ask someone that actually has the real thing that can put this through a machine that flattens it down with these big circular heavy rolls. So it rolls through this and it becomes this beautiful flat surface. Why the hell would we flatten it? You might say.
Because it looks more beautiful, right?
And you can do so many things with it, right? No. What we wanted to do, trä, which translate into wood.
Yeah.
It's a high-rise wood building, right?
Yeah.
And we would have loved to make a wood facade.
Yeah.
But because of fire and legislation in Denmark, we're not allowed to do that.
Nope.
So we looked at something we find is just as beautiful, which is the bark. The surface, again, a facade of a tree. It has grooves, it has dents, it has a lot of mistakes actually in it. It's one big scar, full of mistakes and odd things that replicates and connects and creates fantastic surfaces that really are pleasant for our eyes and our feelings. So what if we could do something with that on our steel facade? So it had a kind of an image of how bark would look if it was made out of steel. And we have steel with a lot of mistakes in it and surfaces and scratches and holes. But if we could flatten it as we could here, we could create a groove in the facade so it would differentiate. And these are all different examples on how we could use these flat sheets, which is the dark ones, together with the normal sheets next to it and start to have a facade. What do you mean normal sheet?
The normal sheet is
the normal trapez sheet.
Ah, okay. So the thing is that the flat sheets become
the groove,
some kind of monochrome tone.
Yes. So
right?
it becomes the groove here, and then here you have the normal trapez, you can say. What is so important now is that sustainability communicates, and that it also tells everyone that goes around in an urban context, sees these sustainable buildings, that you can change behavior, that where materials come from is different. It's not virgin materials from mines or from nature. It's something that we already excavated and has in our urban context that we can transform into beautiful new aesthetics and architecture. And the big question is, what type of aesthetics is it that we're seeing? Because it is a paradigm shift, because the surfaces that we allow scars and mistakes from a previous building to become part of a new aesthetic is very different from what we've done before, where it was a zero mistake culture. All of a sudden we allow it. And we allow it because we can see, just as you're saying, that we save CO2 and we can create beauty out of it. It doesn't have to be a new oak tree or a 300 years old oak tree that we try to build with. It can be something that has almost no value, that we can create matter, beauty, and identity from. And I think that's so important, and we see it with the brick facade, that it's a problem that becomes a potential, a solution, and a discussion point. The same with the steel, that all of a sudden goes from being useless to being one of the most important facades for metal sheets in the future. And I think that's educating every one of us that works with this, and hopefully also for you guys, inspires you that even though it's just one building, if it reaches you somehow, you know, it starts to grow and has so much more matter. We're going to meet the people who's actually the client that has planned this building together with me, and that's the real important people.
The real royalty are these
over
guys,
here.
right?
Yes, exactly.
So this is the people who get shit done, and this is the guy who sells the shit.
Sells the stuff.
Is that the thing?
That's the real McCoy.
And this is a guy moving a piece of fence.
Perfect timing. So we have the king, the queen, and the prince. and Rune. These are the guys from Kiltene Hindby, and with every project there is someone who actually develop it. And so develop and planning this project, this is you guys.
How did you guys get the idea that this was the site that you wanted to build a totally sustainable building on?
Actually, we decided not to build down here.
Okay, great.
Because, you can see it actually, but we decided because a lot of other people wanted to build on this side. But then I met Anders, and we had a lot of beers, and we talked about doing a project together. And this possibility came up, but we were pretty late. So we only had 1 week, and the other guys.
Are you serious?
Yeah.
So we came up with this idea of a building where we only use the concrete where it's really needed, and then we changed the concrete where it's not needed. And I said to Stina, this talk about sustainability, it seems like it's not going to go away. So we have to learn a little bit.
Oh, look, he's hugging the
Another
tree.
tree hugger.
Remember the episode where I hugged the tree? Look, this is instinct. This is instinct.
Yeah.
Rune, this is instinctive.
It's a competition, so you have to come up with a suggestion on what you wanted to build. And usually we do these renders, and we go into municipality and say, this is the building we want to build. But we didn't have the time, so we actually wrote a letter instead to municipality and said, if you allow us to win the competition, we will build a building out of reuse materials and tree, and only use concrete where it's needed.
I don't know if it is the most sustainability. That's not important for us. It's important for us that we learn. It's important for us that we can teach other people in the developer business and we can give them the courage to do like this.
We went to a pension fund and asked them if they wanted
PFA,
to join
right?
a PFA, and asked them if they wanted to join us with this a little bit crazy idea. And they were saying, let's do it. And we were actually a little bit surprised when we started, because we thought we were way behind everybody else in this development. But we found out that a lot of this talk about, a lot of it is still talk, and we're talking about it. And sustainability has become something that we can tell to each other.
We need to talk about money.
Yes.
So, how much more, when you guys are sitting here, you know, Henrik is like taking all the ideas and saying, yeah, okay, you guys should know this is going to be, how much more does this building cost compared to traditional building?
Maybe like when I actually would start another place. When we started this building project, we said to the pension fund that everybody involved in the project should say okay to earning half of a normal investment.
Okay,
so we decided on that together with the pension fund PFA, because we could see that it would probably become 10-15% more expensive to build like this, and then you put down the margin of what you made.
Okay, great.
So what we learn here is not staying in our company or with the pension fund. We have committed to sharing this with everybody and with the ones who's in competition with us. So we share the knowledge that we get. That's part of the idea.
Not only do you lose 50% of what you usually win, but you also say, hey, let's share it all. But you guys said, we want to earn half of what we normally do. That's unusual, right?
Yeah, but actually there's a part two of that, because when we went to talk to the tenants, we actually had a meeting with a law firm that we were talking about this project, and
tenants mean
they want to hire these buildings, and they actually said to us, we started talking about building in wood, and they actually said to us, we don't actually care about that, we would just like to hire the top of the building with our law firm. And we actually closed down the meeting, and we went home, and we said we're not gonna hire out to these people, because if they don't, we use so much energy on this project, and if they just wanted the view, it's not enough. So we actually decided that we want to talk with our tenants about why they're moving into exactly this building and what can they do in their business. How can they move a little bit, because then our impact is not only the building, then it's also the tenants and the tenants' company and the employees with the tenants and so on. Part 2 of that was actually we also made another decision.
Yeah.
We decided to increase the rent level with 25%, because we said, okay, we actually think that the companies are willing to pay for this to move into this building. So we actually decided with the pension fund, instead of making half of the money, why don't we decide to make 20% more by increasing the rent level of this project. We have used so much energy, so it's fair. Yeah. And actually what we found out is that the market is willing to pay for a building like this. We didn't want to do a building that we could only do this one by making half. So actually that's why we decided, can we make it a normal business case where we actually can get a normal profit? Because if we can do that, then it will not only be us and Anders doing this, then we can really make an impact.
And that is reconstructing the world.
Today, we're going to talk about the use of waste wood in this building. And in EU alone, there is 60 million tons of waste wood every year.
Quite a lot.
It's growing. Most of it, especially in Denmark, where we have around 400,000 tons, is incinerated.
Yeah, and there's a reason why we're doing that in Denmark, is because Denmark is one of those countries in the world that has the highest amount of central heating system. And central heating systems are really, really well. It's super fantastic. If it was not due to that we burn every fucking material in the world, right?
Exactly. It's kind of a counterintuitive of what we're doing
hey,
here.
look how good we are. Hey, look how
Burn
much
the
we're
shit.
doing bad. Great, I love it.
All right.
Okay, so and this material here, is that the floor for here?
This is no, it's not the floor for here. This is in all the entrances,
Okay.
and there is going to be some cafes and some more public functions in the building. They need a floor that can really take some beating. So the cool thing here is that we've managed to get a lot of waste wood into the building.
Yes.
It's very close to 1/4 of all the wood in the building.
Yeah.
We have 4,000 cubic meters of wood in træ, which is a lot of wood. So today we're going to talk about our different floors, because we also have some wood floors on, like all floors here. They're over there. We're going to talk about them. Then there's the walls.
We'll come to that. So let's start with this. This is made out of blocks from what kind of industry?
It's blocks from the wood industry, and one of our first mock-ups we did was this one, and it was more to show that if you took, this is you can see that it's from an old, if you go close, it's from an old roof structure. So it's a beam from a really old building. So it's cut in pieces. When you cut it in this way, all these structures that you see are way harder this way than the other way, which means that you could cut a really thin piece and even cut a piece of wood that's not high quality. So it doesn't have to be oak, it doesn't have to be kind of a slow growing tree or type of tree. It can be something else.
Okay, so
in this case, some of it comes from offcut in the wood industry, because only 25% of the wood from a trunk becomes actually wood that we see
25?
Here. Yes, so we have 75% waste from the wood industry. This type of waste.
It's not waste anymore due to you.
So this particular floor, like everyone, at least in Denmark and Scandinavia, from the 70s knows these kind of hardwood floors.
It's called parquet.
Parquet.
Yeah.
And at least my generation, you're way older than me, right?
I'm not way older.
But do you still like it, or?
No.
Good. Then we're probably same generation. But
I only said that because it made me feel younger.
The interesting part here is that it's still being sold a lot because it's a very efficient wood. This is from Junkers flooring. That's one of the biggest parquet floor manufacturers in, I think in
the world.
maybe in the world.
Maybe.
World's biggest. But when you have a large production, and what is interesting here is that they, where they use energy
Yeah.
on this is pine and birch and these types of wood types,
Yeah.
they press it super hard. And when you press it super hard, it becomes a hard wood floor.
Okay.
Makes sense, right? So what we came up with was that we just mixed all the different types of wood wood types, so
Yeah.
birch,
So this is both birch, pine, whatever.
all kinds of, and actually it's not the hardwood. You can also get, I think they have oak, but it's more particular like redwood and lighter types of wood that you can then compress so they get hard. These different colors are then mixed everywhere here.
Yeah.
So we just collect them and in the different lengths, adapt them to this floor. So they are, as you see here, you
Yeah.
have, here there is maple, we have beech, and
Oh, so it has
then-
like a coloring. It has a coloring. Look at this. It has a coloring. It'll
Effects.
have a coloring play effect, right?
exactly.
It
So
actually
it's
looks
just mixed together. So
Yeah.
in a random way, they create a pattern,
That's super cool,
which
man.
is pretty nice.
Yeah.
So,
But this is an enormous amount of wood.
yes,
So what
So-
we've been going through now is recycled
Yes.
flooring in the bottom, recycling flooring at every level,
yeah.
recycling these guys in the walls.
Yeah.
What do you use? Normally you use aluminum studs or new wood studs.
Yeah, you would use. You would use in the kind of 90s and in the beginning of 2000. You would have all these kind of steel, these perforated steel
Yeah, I know.
surfaces where you would have acoustic material behind it, and altogether
Oh shit.
it's almost 1/4 of all the material, like wood material in the building. So even though the slabs are massive wood in 200 millimeters, so they are this thick, and we have the columns that are 40 by 40 centimeters,
Yeah.
then still covering the floors, the walls, the ceiling, and these glass walls partitions for meeting rooms, we have so much material that we have
Yeah.
recycled.
So how much cheaper is this project, or more expensive?
So actually, you're walking in that direction. You're walking away from the
I'm
product.
still fucking trying to show you how to make television. Is that if I, the host, keep walking, then you follow me.
I'm trying to show you how to build a sustainable building,
Yeah,
and then
but-
you're on my ass all the time. I don't do this every day.
I'm not on your ass.
To me
So
that I can't
economy.
walk
Let's
after
talk
you,
money.
and it's like,
I'm the Wall Street guy. Where are you going?
why are you not following me? We were supposed to walk.
Yeah.
So if we take this type of flooring, the parquet flooring, that is actually a really economic, meaningful product. It's the same price as new Junkers flooring, parquet. So it's not more expensive, it's not cheaper, but it's super sustainable choice. So that's pretty cool. We like that. And this is actually way more expensive than that floor. But it's also used for the entrances.
Yeah.
And the entrance is actually a floor that needs to take a lot of water, beating materials coming in and out.
People
and so on.
fighting on it.
So it is a more expensive floor, but again, there is so many types of flooring and economy. So this is kind of a high-end floor, but it's absolutely economically feasible to use. We have it in the canteen and we have it in kind of the entrance.
So
area.
it's a bit more expensive.
Yeah. So in general, most of these products are cost neutral.
Yeah.
A few of them is more expensive than the product we would have chosen normally
Yeah.
for this. And A place where we are looking into something that is more expensive is the glass partition walls that are for meeting rooms.
Yeah.
There we have a product that Deco is making,
Yeah.
where all the frames are waste wood, as I said,
Yeah.
and it's recycled glass. And that product is more expensive.
Today, we're going to open our minds and hearts and embrace concrete. So we're going to talk about concrete today.
We're going to talk about concrete. We're going to mainly talk about how you use concrete for the most important thing of the building and how you always are thinking about bringing down the concrete. And just very recap for the audience out there. Why do we not like concrete, Anders?
We don't like concrete because it stands for 8% of the total CO2 emission globally. So it's a big sinner.
So the first thing you did, trying to minimize concrete, what was that?
So, is that a helping finger?
That's my helping finger. That's
Pointing
my
finger.
So the audience doesn't notice that I'm trying to help you.
Okay, so one thing we did to reduce the use of concrete in the building was to have no basement. So usually we dig the whole side out and we cast a lot of concrete.
Yeah.
Instead, we had no basement, no parking. We only have a small basement, which is for bicycles.
So what we're looking at here is a traditional dugout basement, and that could be in various depths, 2-level, 3-level, whatever, right?
Yes. So what happens that is not so good is that you dig out a lot of dirt,
Yeah.
mud, whatever there's down there, and then you drive it away. So there's a lot of truck driving to get rid of what is there.
Yeah.
And then you hammer these walls, steel walls in,
Yeah.
which is also like really intensive in steel and CO2 emission to create those.
So you're already
So
there.
we're not even starting to use
exactly.
concrete.
You're not even beginning.
No.
We're already in
Yes.
minus.
And this is actually really incredible that when we calculate CO2 with life cycle assessment, these two things are not calculated in.
The steel walls.
The steel walls and the removal of all this dirt.
Those squares down there, right?
Yeah,
Those are the fun, the anchoring on this building, right?
exactly. I mean, now you can see where the containers are over there.
Yeah.
That is the footprint of the third building.
Ah, okay, yeah.
And the interesting part here is actually that the buildings that are 6 floors high,
Yeah.
and this building that's 20 floors high,
Yeah.
has nearly the same amount of pillars,
Okay.
which is interesting in the looking at how many more square meters we are actually building. So even though we are up high with a light building compared to a heavy building.
Let's get some comparison. Now we saw a traditional way of doing it compared to this one. The amount of concrete for foundation at 3. What is that?
Yeah. What you can see here is that we've not digged out.
No.
So we have removed earth, but
Like a couple of meters or
not
one-
even.
Okay.
1.5 meters, something like that. And then we put these vertical pillars in.
Yeah.
And then after that, casted a platform.
Yeah.
And you can see that there's not these steel walls around here.
No. So
Because
you
we didn't have to go down, and it's a retaining wall for
you
the
don't
dirt.
need to.
You don't need to.
It doesn't expand because the weight of this building is much lower than the one over there.
Yeah.
Okay. We've covered in early episodes how much the wood is a part of the bearing structures and the wooden floors.
Yeah.
What is the amount of concrete that you can leave out of a building like this?
In this case, it's around 85% of the material that we leave out and in weight. So if you would weigh this building, I believe it's around 13 or 15,000 tons, and it would have been over the double weight if this has been built in concrete. The fact that it's so much lighter is the volume of concrete that we're leaving out, because that is the difference. For many years, architects has just loved this surface.
Yeah.
I mean, it's just, don't forget that the whole modernism, just everything was out of concrete. We loved that it was possible to build large buildings, complex structure and spans, and get this surface.
Yeah.
So it's also a mindset change
Yeah, it's
that
an
we are
aesthetic.
hogging. We are hogging the wood, and all of a sudden, this is the bad guy surface that we don't like. But for the past 100 years or 50 years, this has been a symbol of high-end architecture.
Yeah.
You should ask me. So is there a future for concrete? The world's most sustainable
Then you need to-
architecture in the world.
Most sustainable architecture, yeah, that's nice. That's a good thing. You feel motivated by that one. Most sustainable architect in the world, Anders Lendager. Is there a future for concrete?
No. But there is a way of rethinking concrete, so there could be a meaningful way of using it. So we should use concrete the places where we don't have any other alternative. But the interesting part is actually we did an analysis of that, and we call it the concrete pyramid, and it's kind of like the food pyramid, right? So
Made out of concrete.
you shouldn't eat it. It's just
I get it.
You draw things.
I get it.
You should understand.
Yeah, I get it.
So, in the top, what do we have in the top?
And we have the chalk,
In the top, we have the stuff we want the least of.
yeah.
And in that is the concrete that we need for parts of the building that needs to be super stable.
I get it. I
For
get it.
instance, our ground floor here. So you need foundation in the ground. There's no alternative for that.
Yes.
And so when you go further down in the triangle, then there starts to become alternatives. Both new types of cement or concrete, but also the fact that you can disassemble the concrete. So we need to build buildings where you can take the parts of the building and disassemble them afterwards. So when a building is not in use, you have to take it down and use it for something else.
Yeah.
That's in the middle, and then you start to have a building that has almost no impact. When you direct reuse concrete, you use only 2 to 5% of the CO2 emissions than when you cast them.
Yeah.
In the bottom of our triangle pyramid,
I am there. I'm at the bottom of it.
you have all the pieces, staircases, all the pieces that are part of a building that are light and can be moved on, inner walls, all of that stuff.
Yeah.
That's also something that can be designed for disassemble and reused again and again.
Yeah, so it's an overall material pyramid, right?
Yes.
So like
But the
concrete and aluminum and all that is in the top part, and you have...
No. It's only concrete. It's a concrete pyramid.
Okay. But
I
why...
shouldn't have said food, because then you think
No,
all
I
kind
was
of
like,
food. So I could say the oat milk pyramid. Would that have greens in
Okay,
it?
so what you're saying is, in the bottom, everything made in the interior and that's made out of concrete should be able...
Maybe
He actually
Maybe
looked
you
at
should
it. He
take
actually
them-
looked at his watch, like, okay, how much time do we have with this idiot?
do we have more?
Tell
maybe
the people about the bottom.
a power
of the,
nap is maybe needed.
No, you had a power nap.
If we were to build this building, for
Yeah,
instance,
yeah.
where the columns were direct recycled columns,
Yeah.
the slabs were hollow decks that was direct recycled.
Yeah.
And only the parts where the foundation needed to be casted new
Yeah.
with the best sustainable concrete we could.
Yeah.
Then the reduction would be
Insane.
really high.
Yeah.
And that's where I see a future for concrete, that it's more kind of leasing almost, or you're borrowing the materials to the building, and you can disassemble it and use it elsewhere.
We're back.
Yes.
And as you can see, the
Stuff
camera
is
can see, the building is going well. Tree is rising.
Yes.
Yes. So
Yes.
today,
Yes.
what are we going to talk about now? Because now we're inside, right?
yeah.
Now the inside of your vision is being planned.
Yes. And one thing that you can notice and maybe hear right now is that there is a lot of sound.
Yeah.
And sound is a very big part of the city. Noise, especially.
I know where you're going. Nice segue. I didn't think about that. You are now a pro.
Thank you so much. Okay, so the problem is when you do an office building, then you want people to be able to concentrate, and basically real bad noise can lead to sicknesses and stress and all these symptoms.
Yeah.
So to make the best possible work environment, we need to have some acoustic material that absorbs noise, both from
and that
inside.
starts now? That starts now. That's what you're putting into the building?
We start planning now, and of course when we designed the building and do all the drawings, we had to make some conscious choices about what materials was possible to use for acoustic purpose.
Okay.
So and normally acoustic materials is not sustainable at all. Most acoustic material is actually made out of material you also would use for for insulation purposes outside of the building.
So normally like mineral wool,
stone that's been melted, or glass that's been melted. That takes a lot of energy.
Sounds
and of
super
course,
unsustainable.
It's unsustainable because it's so much energy that you put into a material that needs to absorb an acoustic purpose. And the reason why we've been doing that for so long and that it's actually a product is because of fire. We looked at some different waste streams that is out there in the consumer waste industry, or the consumer industry that becomes waste. And there's two super big streams.
Food waste.
Food and and waste and textile waste. And
what is waste?
That's when it's really bad.
That's poo waste. So you went you aborted that plan.
That was just a wrong formulation.
I can't help myself, but there's no poo insulation in the building whatsoever. I just want to emphasize that. Don't take that information.
It could be organic waste.
Make
actually.
it okay. Fuck it. What did you come up with?
We looked at two types.
Okay.
So one thing is textile waste. And there is insane amount of textile waste. There's 5.8 billion tons of textile waste.
Yeah, keep going. I'm just doing television where I show something different.
I just have to be sure. It's 5.8 million tons of. We have to take that again.
Normally it's getting recycled into other textiles, and it needs to be clean in the fraction, right?
Yes.
Yeah.
The problem is that a lot of this textile is just incinerated.
Yeah.
And these textile fractions, they come from industries and they also come from fashion. So the interesting part here was...
Directly from fashion. So
from fashion to waste.
Designers in fashion should be incinerated? No, I didn't mean that, but you know what I mean.
Okay, so that would lower the carbon footprint.
That would really. Take every fashion person, either incinerate them. It's a very. I know we're gonna
or shred them.
I know we're gonna get so much.
And you would get this.
Yeah, we'll get so much in trouble for this.
What if we could take threaded textile and put it together, compress it, and try to make a firm bat like this. This is a bat. And it was super difficult. First of all, how to make it stable, that it wouldn't be sloppy, how to get things to hang together.
Yeah.
And over some years in the development, we actually managed to do a product that is all types of textile, from cotton to more, plastic textiles and so on, mixed together and actually do a product out of it. But the interesting thing here is that by using this material, we can recycle 3 kilos of textile per square meter, which means that that's quite a lot, especially in a building like this, where we have 14,000 square meters of footprint.
Yeah.
And when you look at the acoustic surface you actually need all the walls here and the ceiling. So it's even more than our floor area that you need as acoustic material.
Yeah.
The problem for us in this building is that it's an 80 meter high building, 78 meters high building out of wood. So fire legislation here is extremely tough. And we couldn't get this approved because we needed to put way too much chemistry into this product for it to be fireproofed. So we said, no thank you, we'll try something different. Okay, so what could we then do?
because we were looking for a really price effective product at the same time, because acoustic material is super cheap.
Yeah.
So what to do? And we were up against a benchmark product, which is a cement-based sheet, which is a product where you behind it also need to have mineral wool. So you actually have two products to live up to these standards.
Two layers
of
melted
things
stone.
that we don't want to do.
Yeah.
Instead, we could just have this product.
And this is made out of PET material?
This is plastic. So this is waste plastic. And waste plastic from, from plastic bottles. And
just a minute. Before you go ape shit in the comment that, bottle should be bottle, which we all agree on.
We
We actually like clean fractions. Just to correct Anders, this is dirty fractions. This is mixed together of all kind of shit. Right.
Mixed of all kinds of stuff.
Yeah.
The fact of the matter is that we have so much plastic waste from industries from all over the world, and most of these things are just ending up smashed together and not being able to reuse in a as you say, a clean fraction.
Yeah. What about the money? What about the economy?
Yeah. What about the economy?
Is it like
it's a very good and important question, and I will tell you one thing. This guy really surprised us a lot, because
me or somebody else? The guy who made
I'm
this?
pointing to like under you. So
This guy. Oh, sorry.
that guy surprised me a lot.
That's a totally different show. You can check it out. It's on Pornhub.
What really surprised us a lot here was that they were a lot cheaper than the normal choice of acoustic sealing.
We'll put a big sign saying this is a no-brainer.
This is a no-brainer of reusing a lot of waste plastic for a really wonderful purpose, and it's also really nice.
Did you make it? Did you develop it?
No, we only made the acoustic, the textile boards.
Okay. But
so
together,
these were before.
Together with the person who made this?
No, it's two different.
Okay.
But they are sold
I'm
the same
really
place.
trying to give you some kind of credit for this.
I can't take credit. This is a pretty crazy fact. That
it needs to be fucking crazy if you put it up like that.
It is pretty crazy. When we build buildings,
and we
do, between 6 to 10% of all the new materials that comes into a building site turns out to be waste. New products. Windows, especially in high-rise buildings, has been playing since the modernism a really, really serious role. Basically, they've been built out of steel, they've been built out of concrete, and then they've been built out of a lot of glass.
Yeah.
Basically, only glass.
Modern buildings.
Modern buildings.
A lot of concrete inside, a lot of steel outside with window frames. We know it all, right? Like this, actually, where you have the whole facade in a building built like this.
Exactly.
Yeah.
And so there is, of course, some things that are really important with windows is that we get daylight in, and we get a beautiful view. And the higher the building is, the more beautiful the view.
Look, a beautiful view.
Is. So, and the problem is that producing glass and windows is emitting a lot of CO2.
Yeah.
We are normally using aluminum framing.
Yeah.
So all the framing of windows are normally massive aluminum.
Okay.
And they're called curtain wall facades because it's basically the whole facade.
Actually, like you have elements of there, right?
So what is interesting in this building is that we, of course, have some massive walls with smaller windows in that is actually quite big. And the places where we wanted to have the best spectacular view, we have these very large windows partitions. The interesting part here is that all the framing of the windows are wood. So we have minimized the use of aluminum and steel a lot.
Okay.
So that's an important step for this building in the process of using more sustainable material, is to go away from steel and aluminum. So one thing we
are working on, and we are going to have that. It's only 100 square meters or 200 square meters. I can't remember. We're going to come back on that.
We'll put the correct number on the screen.
Which is in the ground floor. And that is actually where we're using discarded windows from the industry. Because what happens often is that you misproduce these facade windows, which means that if this one is just 1 centimeters too wide, it's waste. And these are just crushed and become recycled glass that needs to be remelted and so on. That's really bad.
I can't handle the truth.
The truth is
I can't handle it, Anders.
But you have to. You heard much worse things.
Seriously, every time we talk about...
And there is a Danish manufacturer of glass windows.
Yeah.
Could be roof windows. It could be something like that. They have between 30 and 40,000 square meters of waste, and that's just for a pretty big manufacturer, but just in Denmark. So imagine how many windows that are discarded, that has scratches, or actually, are just thrown out because they were a little bit too big. Unfortunately, because of energy calculations, just a comma here and there, the calculation said we were not allowed to use these windows everywhere in the building. Instead, we're producing all these new windows, and we could have done it everywhere in the building. And it's a really interesting question. Do we use our energy in producing new products, or do we use our discarded waste windows?
So what you're saying is, if regulation could have managed to do
an energy calculation,
an exception.
They
could have said, okay, you can discard. You can use the discarded windows, even though you have 1.0 whatever.
Yes.
Okay.
Exactly here, this is going to be a wine cafe, whatever. Something.
No shit.
There's going to be a terrace hanging out here where the bridge passes over there, and then it goes down and hits the road down there. So it kind of have a slope. That's why it's a cool view. But we're going to see that
later. There's going to be a wine bar here?
Yes. And a terrace here.
When you can walk to the city?
Yes. That's cool, right?
I'm going to grab your dick. You have a big uterus, man.
This is actually waste aluminum from
the outside.
The outside. There was supposed to be mailboxes, but the mailboxes manufacturer
for letters
didn't like that there was water on the aluminum before they manufactured them, so they discarded 13 tons of aluminum.
And then you said,
and then we said, yes.
Hey, I'm the most sustainable architect in the world.
Yeah,
can I buy that?
And we got them super, super cheap. And now they're way higher quality than what we normally get to do that.
Normally I wouldn't say it, but yeah, a crane did something there. It looks like shit. I'm just saying. So,
but the cool thing is that inside the building, an office building, there's meeting rooms. And there is just as much glass in the inside of an office building as there is on the outside. And that's the easiest glass actually to recycle. So right now, we hope it's going to be in the whole building that all glass meeting rooms is going to be old thermal windows from old housing units.
Like in all the windows there? If all the glass walls?
Exactly. But right now we know it's in all kind of the larger meeting rooms in the cantina and in the meeting floors and so on, and we hope that it will be on like all floors, but they are more expensive. We talk about economy, and these are a bit more expensive.
Okay. Most sustainable architects in the world. Why did you put a giant wood piece in front of the window? That seems kind of stupid.
That is.
Imagine I'm being a kid. Oh, mommy! Oh, I'm stuck. I can't, whatever, I can't get ever.
The most ridiculous host in the world is stuck in a beam. The reason why is that we wanted so much to show from the outside that it's a wood building. So we on purpose let the windows sit in front of the main structure instead of pushing it away, because we get aluminum cladding of recycled aluminum on the facades, but we want to show that it's a wood building. So that's why it's in front of the window some places.
That's real architecture smooching right there. I've loved to have been a fly on the wall like,
Okay, what I imagine is that people all over the world will go by, glance at the window and say, hey, it's a wood building in there. Ooh, ooh, ooh. That's what you imagine, right?
Exactly.
I know.
Yes, that was exactly what happened.
Is that a course you take in architect school?
Yeah, it's
called the bullshitting of developers.
Yeah, it's around 5 years of education.
Yeah, it's like you have to wear a turtleneck every day.
Turtleneck,
Okay.
turtleneck
Sorry.
and glasses.
Okay. So
you have to have Moscot glasses on.
Okay,
to bullshit.
my is not actually. So, but anyway.
What?
So let's talk economy. We always finish with economy, honest.
Yeah.
What is the economy of this shit? Windows, sorry.
The economy of the windows. I think that in this case it's a cost neutral product.
Ooh.
Because I mean the windows, the glass pieces are really big, and they're not sustainable in the manufacturing of these big sheets, and that would have been the same for a normal facade.
Okay.
But where we are saving CO2 and are doing something meaningful is to make this out of wood pieces. And
Yeah,
this,
so all this
so Krone is our manufacturer, a Danish manufacturer of windows, and they've done these beautiful wood windows, and they're of course not super cheap, but it's also an expensive component of a building. The upcycled windows that we are doing on the ground floor, there we are saving 87% CO2 compared to a new window.
Yeah. Oh.
So 87 on those ones down there. And that's why I'm saying the interesting discussion point here is, you know, do you want to use a bit more energy in heating, cooling over 50 years versus the energy used on producing new windows? And that's the ongoing discussion in this. What makes the most sense when we are on, you know, very small decimals of windows becoming better or worse?
Are you ready?
I'm ready.
So I'm gonna open the door, and you're gonna just go blasting out like, "Welcome to Reconstructing the World," and you're gonna go blah blah blah, and you're gonna throw some hand moves. Are you ready for that? Or do you want to play it more seriously?
I'm ready.
Are you ready? Okay, go.
I can't. My ego can't come through the door.
No,
Can you open it
try.
again?
I heard a rumor that today we are talking about something called Living Lab.
No, but what is Living Lab? It's not this. It's this floor, and then what? 3 floors?
So one of the things that we would have loved to do, because when we do these projects, and we've showed you a lot of different materials. Some of them we invented ourselves. Some of the things that we could find out there that made sense to use, that are recycled, upcycled, and wood materials.
Yeah.
But in that process, of course, there are some materials that we just dream about using, but for some reason are not allowed to use. It can be because that they are, one, too expensive, or it's such a new product that the company hasn't really moved that far yet or ready to scale, or they are just not used to working with like big construction companies.
It's an experimental floor.
It's an experimental floor, and so it's both
this
going
is a
to be.
swinger club. You put in a swinger club.
No. Well, you can see a swinger of upcycled materials on one floor, a swinger floor of recycled materials on a second floor, and a bio swinger floor, which is maybe more you. And here we have on the interior, like that's rock wool. There's on the interior in these buildings direct reuse of rock wool, and it's actually possible, as we said in another program, just to direct reuse mineral wool beds and put them in again. And next thing, we just talked about the floors on the other, floors, which is this parquet flooring. But this is different because here it had to be direct recycled, and this comes from Gellerup. And Gellerup is in Denmark. It's a ghetto. It's a ghetto it's not a ghetto anymore. It's being changed. But in this refurbishment, thousands and thousands of these floorings are just being thrown out. Now they're starting to be able to actually buy them and save them. So here you can see they are a bit more rough on the edges. So here you can see that it's actually been joined. It's a different color. They're more rough. There's even some over where I see it here, where you see that it's
maybe there's been a water damage or something like that. What we could have done, just to say, this is getting a little bit nerdy, but normally this is for a carpenter that needs to put in floor. This is, you would call it a fucking nightmare.
That's the official. That's the official.
That's
wording.
official wording. A fucking nightmare.
So this is
because,
a fucking
because
nightmare.
all the joints are then a problem. What we should have done, or what would have been done normally, is that you clean it up. So you cut it off and take all these off and redo them so that they're sharp.
Yeah.
So assembly is quick. But here we didn't want to do that much work with it because then it becomes a different upcycled product. So here, yeah, they have to deal with this on site. So they're not going to be as tightly laid out when they're finished. But we can show that on a later time, but it's going to work fine. But that's the point. This is the toilet. So
That
here
is the toilet.
it's
that's the
yeah.
toilet.
So you have to be able to squat and hit it.
This is what we call
It's
a precision
really-
toilet.
And that's the most sustainable, not having the ceramics at all. And it's the first time in
And
the
it's
world
all-
that we're allowed to do just a hole in the floor.
Can I do the architect smooching on this one?
Yeah, you do it.
So you're here, right?
I'm here.
So what we did here was we looked back in time, we looked through all humanity saying we need to go back in time, seeing how did we defecate, how did we dispose of our bodily fluids. We always did that through a hole in the ground. So we have introduced a hole in the ground. This is a brand new revolutionizing sanitization issue where we are introducing the hole in the ground. It will also do a lot on your calf, a lot on your hamstrings. So you'll go here and you precision, you need to be very precise, extremely precise.
So you don't have to go all the way down.
Did I
You
sell
don't-
it? Did I sell it?
You
well?
sold it so good, but I just really have one question.
Yeah.
Is the size of the tube, does that fit everyone? It's a unisex?
No, what I do is I just zip up and then I put my.
So in here, we're going to direct recycle as much as possible. So here, it's going to have tiles everywhere. So it's direct recycled tiles that comes from another building. And also the toilets, which is something, and it's really odd, but it's very important for me because toilets, sinks, all these fixtures, we throw out all the time and they're actually okay. So we wanted to show for a new office building that we can take an old toilet in. So in this building, on this floor, we're going to have old toilets that are absolutely cleaned and fine and working, hopefully.
From where?
Let's see.
Do you know the origin of the toilet?
I don't know the origin. It's going
Like
to
an
be
old-
random
An
toilets.
old man outside this town.
It's called Viking Rumpegulve. Okay.
Yeah! They are super beautiful. Look over here. You can see them here. Here,
Yeah.
and these are all offcuts, right?
These are also all. This is offcuts in all kind of different materials, or not in different materials. This is all. I think this is actually
oh,
old.
shit, that is so cool.
It's really nice. The economy. These are way more expensive than the other ones, I have to say.
The one from Gellerup.
Yeah, and
The
also the again floors. These are way more expensive,
Okay.
and they're more difficult to put in. But they're also, I must say, just a notch up in beauty. Let's talk about another thing that's in here, which is in a different category, but also an upcycling product that you can just buy. And we were in doubt if we wanted to use this, but this is actually paper flock.
Oh shit!
So this is acoustic sealing. It comes and it's quite cool way of putting it up. So you have yes. So they just do you have to make that sound every time?
That's how it sounds when you put it up.
They spray it up. The point here is that it's waste paper that becomes acoustic material that's shredded, and then there is a binder, a kind of a bioorganic glue, I think it is. If it's not bioorganic, it's something different. And then it's sprayed up and comes like this. So it's a quite easy, and it's also, it should be very cheap. In one project we used it, it was very cheap. They're saying here that it's not as cheap as the other acoustic sealing.
I don't know what this floor is called, but you can immediately feel this totally different vibe in here.
Yeah.
And the reason why I know it is because I've been working a lot with clay padding, clay interior, and the feeling, the air is super different.
Yeah.
And I guess this is clay
Exactly.
cladding, and it's like, it's fucking great.
It's
it's
such
also a
a
great
different
window.
floor. Maybe you are changing, then we're changing the roles maybe today on this or on this floor a little bit.
Yeah.
But I think you're so right. You can, and architecture is most of the time the senses of like the eyes and also the ears for sound,
Yeah.
and then a lot of different feelings about space and understanding on geometries and so on. But whenever it changes to being bioorganic material, smell has a positive effect, which is super interesting, where chemistry, volatile organic compounds is such a big part of building materials, and all of a sudden it changes.
Is this?
It's clay boards.
Yeah.
So it's clay boards that are 15 millimeters, and then there's wood insulation inside it, wood chip insulation, and wood studs. So this is all organic walls, and it has a totally different beauty to it, and also a different feel. I mean, the surfaces.
But what did you put isolation in the wall? What is it? Is it only the clay board, and is it also insulation?
It's wood insulation inside.
What is this? This is sewer.
It's sewer.
Shit! This is sewer.
It's seaweed.
I fucking love this floor.
Yeah.
I'm serious.
Yeah.
If you stand in here, you can smell. There's a different smell because this used to be seaweed, right? It's called
seaweed.
eelgrass. It's called eelgrass in Danish.
Yeah. The walk of victory. Don't let me hang. Thank you. And even the paint here that you can't see is any different than in other
wall?
floor. Yeah.
This white paint.
Yeah, the
Is
white
it
paint.
our?
It's out. Yeah. Oh, you know that. You're so into it.
I
did you
fucking
read
know
it?
my what is it called? Organic materials.
So it's natural paint. And I've been working with natural paint in a lot of projects.
Yeah.
And it's funny that all the painters, they always say, oh, it doesn't cover enough, it's too watery and so on. And then they start working with it.
And
then they love it.
Yeah.
And it's and they can feel that they also feel better themselves.
Yeah, healthier.
So it's healthier. So these walls are all hempcrete.
Yeah.
So we tested those out as well. It's difficult to see that it actually is hempcrete also down here. But you can't see it, but I wanted to show you that it was hempcrete.
Yeah.
And hempcrete is made out of hemp, but it's
Obviously.
also made out of lime.
Yeah.
And the big discussion here is how much CO2 impact is there when you use lime?
Yeah.
Because you have to, use a lot of energy to create lime.
Yeah, but still, when you're working with lime, isn't there a difference between cement and lime? You don't need the same degrees of burning it.
Not as high, but you are also using it. But when you calculate the life cycle assessment, kind of before in use, like the first stages in manufacturing, it's actually carbon positive.
Yeah.
Because the hemp is sequestering so much CO2, it's growing 4 times as quickly as most other organic materials. So it's really positive there. But then there is the lime, and that's a question about like when you have to take this down, what do you do with it?
Yeah.
And some say that you can crush it and actually use it for what do you call it? Fertilizer. Yeah.
Yeah. Very
So,
Russian.
But
Very Russian.
but it's a little bit difficult when you have paint on it.